Explain voltage transient with rise time, steepness and tail time. So a voltage surge transient wave is a sudden and temporary increase in the voltage that lasts for a very short duration, usually caused by switching surges or switching operations, lightning strikes or faults in electrical systems. It refers that the transient voltage surges are of duration of microseconds. The wavefront refers to the rising portion of the transient voltage wave like this. This is, you can see this blue line. It represents how fast the voltage increases from 0 to its peak value. The faster the voltage rises, the steeper the wavefront. This waveform is steep fronted, that means it reaches to its peak value in very short time. This time is known as T1, rise time. The value of this rise time T1 is approximately in the range of 1 to 5 microseconds. You can see this in this. The rise time is nearly 1.2 microseconds. Here it is written that wavefront is 1.2 microseconds. So it is 1.2 microsecond is the rise time. Steepness is the rate of change of voltage with respect to the time, that is dV by dt. That is, if we consider the voltage as 1000 kilovolt and rise time is 1.2 microseconds, then the steepness can be calculated like 1000 divided by 1.2. So it is 833.3 kilovolt per microsecond. This is how the voltage rises suddenly from 0 to its peak value. A higher steepness means a more abrupt rise in the voltage, which can cause a severe stress on the insulation. The steepness depends on the factors like source impedance, the propagation medium, and the load characteristics. A lightning impulse wave is often described as 1.2/50 microseconds, meaning 1.2 microsecond it is a rise time, that is the time taken to reach its peak value from 0, wavefront time. 50 microseconds it is the time taken for the voltage to decay to its 50% of its peak value, that is wave tail time. It is referred as 50 microsecond in this. And steepness that I have already gone through is calculated by maximum voltage divided by its front time, that is TF, that is the rise time. So rate of voltage increase, so it is calculated with this. So here from the peak value to reaches its 50% of the value, this time is known as tail time, that is wave tail time. It is in 50 microseconds. This is the standard impulse transient voltage waveform. This is applied to check the equipment operation against the transient. Safeguarding and everything is checked by applying this magnitude voltage waveform, that is 1000 kilovolt, 1.2/50 microsecond rise time and fall time respectively. So this is about the voltage transient with rise time, its tail time and steepness.